In today's lesson, we're going to be looking at graphical displays of data. So we're going to be looking at how we can graphically display a data set for one variable. And the reason we want to do this is because we want to be able to visually show what our data is or how it's distributed or how it looks in an appealing way, because just presenting a table full of values doesn't really give us a good sense of how it actually looks. So just as a warm-up, take a look at the following graphs that represent the data from Stats Canada used in the previous activity, where we looked at the percentage of people that ranked healthcare good or excellent for each province and territory in the year 2000. Reflect on anything you notice or wonder with regards to one variable statistics learned so far. So again, you can pause the video if you'd like, or just take a second to think about, is there anything you wonder or notice about these two graphs or displays? Again, there's not really a right or wrong answer. It could be as easy as, well, how do I make them? Or what do they mean? What do they represent? So those were two examples of the two types of displays we're going to be creating. And what we're going to be creating are histograms and box plots. So histograms we've looked at previously. We've looked at them when we've created our modal intervals in the first lesson of this unit. But histograms are used for continuous data, so where there's no fixed set of values. So that's when we use histograms. And there's two things to keep in mind. Generally speaking, they're very easy to make, especially with technology. But there's two things that we do have to keep in mind, because this is the one thing that we can change. And it all relates to the intervals or the bucket size. And the two things we want to keep in mind are, is the interval size nice? Which basically means, can I read it nicely on the histogram? Can I clearly see where the interval starts, where it ends, and so on? Can I clearly read that? And secondly, do you have enough intervals represented on the histogram? We talked a bit about this before when looking for the modal interval. You do want to have a fair number of intervals to accurately represent the data. And a good rule of thumb is 5 to 10 intervals. Now, there's not really a specific way to figure out how many intervals to use. It kind of just involves playing around with the bucket size to see what represents our data nicely. Again, the good rule of thumb is anywhere between 5 to 10. You can choose more than 10 depending on your data, but generally speaking, you wouldn't want to go below 5. And when we create our histograms, there are 4 specific types of shapes to look for that describe how the data is distributed. But before we get into that, I want to at least touch on, again, just how to create the histograms. So again, if we go to Google Sheets, we've entered our data. I have a little bit more here, but we'll come back to that later. But the main thing is our data set here. I want to create a histogram for the year 2000. So I'm going to highlight my data. I'm going to go Insert, Chart. Right now it's a column or a bar graph, so I need to change that. I'm going to click on Chart Type and scroll down to Other for Histogram. Once I click on that, we can see that it's already set up my intervals. It's already set it up in terms of the number of or the bucket size anyways. We can clearly see the interval goes from 70 to 74. So it's an interval size of 4. Now I may want to change that, or I do want to change that in this case. So I'm going to go over to Customize. I'm going to click on Histogram. And where it says bucket size, this is where I'm going to play around with this. So what would happen if I picked an interval size of 25? If I do that, I can clearly see that from 70 to 90, an interval size of 20, all my data is within that. So my data just is represented as one bar. This isn't a very good interval size because I don't really see how my data is distributed. If I go down to 1, so the interval size of 1, 70 to 71, and so on, Again, I can see it a little bit better. It's not too bad, but I see a lot of values that are all at a frequency of 1. And this doesn't really help me because, again, it's all spread out. I'm assuming that most places are all going to be different, so everyone would be considered 1. So I'm going to play around with it. Let's try 3. So again, I can type in any number I want, and that's going to tell me the interval size. So I've chosen 3, so we can see 70 to 73 and so on. It's okay if there's gaps. That's going to happen. That's basically meaning that there's nothing within that interval. So here we're between our 5 to 10 intervals. We do see a nice distribution here. We can see the majority is in this interval, and we can see that, yes, it's clustered around here. We have a few that are high and one that is low. Now again, you can adjust your titles if you need to. I would probably want to do that because, again, I know the vertical isn't actually that. It would be more, say, frequency. That would be a better option, right? Or number of provinces / territories. I could include a horizontal because this would be my percent. And again, I have my title there. So you might want to change some things depending on what automatically gets put there. But you do, again, want to represent your data. So this would be a good histogram for that data. Now, once you create that histogram, now you're going to look for a specific shape or one of 4 types of shapes to describe it. The first is the uniform shape. And in the uniform shape, bar heights are all roughly the same, and each interval has an equal chance of being represented. So if I look at my example here, histogram for bus wait times, I can see that the bars are all roughly the same height. Right? They all tend to be roughly around here. Around the middle, you could argue that's about 125. So for our data, we would argue that because we're looking at bus wait times, we can see the intervals are anywhere from 0 to 15 minutes, and they're broken down into intervals of 1. This would mean that regardless of when I showed up, assuming that it's just random, if I show up at a bus stop, there is an equally likely chance that I could be waiting anywhere from 0 to 15 minutes based off of my data. Because again, all bars are equally likely, so there's just as much as an equal chance of waiting 6 to 7 minutes as there is from 14 to 15, as there is from 0 to 1 minute. So this is an example of our uniform shape. The mound or normal shape, we've talked about it before briefly in terms of normal distribution, but in a mound and normal shape, the most occurring interval is in the middle. So we can clearly see that we kind of have that peak right in the middle here. As well, with our mound and normal shape, the median is roughly the same as the mean, because again, our average is usually going to be in the middle because the majority of our data falls in the middle here. Our median and our mean will roughly be the same. And the same thing with the modal interval. The modal interval, or the one that contains the most, generally speaking, has the mean and the median in it. So again, this is an example of our normal shape. We have the majority of the data in the middle here, or clustered around the middle, and then we have a few kind of outliers, you could say, or extreme values that are at the high extreme and at the low extreme, or above and below our mean and median. So this would be looking at CO2 released per year by coal plants in millions. So we can see that the majority of coal plants are around the same, with a few being, you could say, more environmentally conscious because they're lower or maybe smaller, and then we have a few that are higher than our average, or the average coal plant. The third one is the bimodal shape. And a bimodal shape is data that has 2 peaks. So I can clearly see in my data, or my graph here, that I have 2 peaks of data. In our case, one at 0 to 5% and one at 25 to 30% in terms of batting averages. And usually when I have a bimodal shape, it means that two different groups are represented. So what I might need to do is I might need to reanalyze by separating the groups. So I would separate the data based on those groups, whatever I determine them to be, and then reanalyze my data. So in our example of looking at batting averages for a baseball team, I have two peaks. And what could represent, or what could the two different groups be that represent these two peaks? Well, if I'm thinking about batting averages, or basically what percentage chance do they have of hitting the ball based on their swings and their turns or at plates, I have a lot of people that are hitting between 25 and 30%. And I have a lot of people that are hitting at either 0 to 5%, so very low or very high. Well, not very high, but in terms of our numbers. So the way that I would have two different groups represented here, if you know anything about baseball, generally speaking, 25 to 30% is high, but generally speaking, these would be regular players. Right? These are people who are regularly going to go up and try to hit. In baseball, there are also players, such as pitchers, who don't hit or who hit very, very little. So these would be, say, like pitchers, or we could say like new players or rookies. Or again, thinking about baseball, there's players that are primarily defensive players, so they usually come in for an inning or two to try to just play defensively, and they're not worried about hitting the ball. So you have two different types of players. So I would reanalyze this by separating the pitchers and the new players from the regular players, or the regular roster players, and analyze them separately. Right? Because then that would give us a better sense of, out of the pitchers and new players, what's the batting average look like? And for the regular players, what does that batting average look like? Right, so we're not kind of skewing our data here or getting two different modes. And again, that's not to say that it won't look the same if I remove the pitchers or the new players, but I would want to remove them, reanalyze my data, maybe change my intervals or interval size a bit, and then for the pitchers separately, I would look at those players individually so they could be a little bit more comparative to players of their own standing, you could argue, or position. And lastly, we have our skewed shape. So for a histogram, a skewed shape is when it is pulled to one side of the range or the other. And there's two types of skewed shapes. There's the positively or right skewed, which means that the data is mostly on the left side, but the mean is higher than the median. And negatively skewed, the data is mostly on the right side, but the mean is lower than the median. And to tell the direction of the skew, it's usually in the direction the average is pulled. So if I look at my data here, I have the majority of my data on the right side. The highest interval is on the right side, but because I have a lot of data points at smaller values, that means the mean is going to be pulled towards those very small values. If I compare 95 or 950 to, say, believe it would be over 1,000, right? Those values are quite high, but I have lots of values or small numbers also included down here. So those small numbers are going to skew my mean more towards the lower end of my graph or of my data. So this would be an example of a negatively skewed or a left skewed shape. Another way you could tell, if I were to draw kind of a line around my points, the tail end, so the part that's trailing off, or the trail end, this is where the direction that it's trailing off in, or that the tail is in, that will tell us our skewed, or the direction. So in this case, the tail is on the left side, so this would be left skewed. So again, different ways to represent it or to figure it out if you're not too sure about, well, where would the mean be in terms of my data. So that was it for histograms. And now we're going to look at box plots. And for a box plot, there are 6 points that are used to create a box plot. And we've talked a bit about some of these points before. So in this, or for box plots, we need to have the minimum value, our Q1, which is the 25th percentile, our median, the 50th percentile, Q3, the 75th percentile, and our maximum value. We do have outliers listed here if present. Another thing to also be aware of, this also depends on the technology. Because depending on the technology, sometimes it may include them or may represent them, sometimes it may not. It all depends on how powerful it is or what type that you're using. So those are the 6 main points that you would generally expect to see on a box plot. And here is a box plot of the same data that we were looking at previously. So this is the percent of people stating healthcare was good or excellent represented as a box plot. And the key points that we can see, we have our outlier. So we do have an outlier here. The first line here is our minimum, or what we call one of the whiskers. Now you might be saying, well, why isn't the outlier our minimum? It's part of our data set. And that's true, but there is a calculation that the technology does that determines if one of these points would be considered an outlier, and then it doesn't include it in the data or within kind of our minimum and to maximum kind of, or box and whisker plot. It only represents it as a point outside of everything as a outlier. So the minimum, or one part of our whisker, you could say, is our lowest point. The first part of our box is our Q1. The middle line is our Q2, or our median. So that's the middle of our data set. The other end of our box is our Q3. And then our other whisker is our maximum. And again, those are the main points of our box and whisker plot. One thing to point out as well, this box is important because this box represents the middle half of our data. And you might recall this from our last lesson on measures of spread, that the IQR looked at the range of the middle half of the data. And again, the IQR was the difference between our Q3 and our Q1. So this box is representing the middle half, so the middle 50% of our data. So again, it tells us kind of roughly where the majority of our data lies. And we could argue that the majority of our data lies between, say, 82% to 86%. So again, that's what this box plot represents. Now, there are different ways that we can create a box and whisker plot. I'm going to show you 3 different ways. And again, 2 of them I'm going to say are the recommended ways. And then the third one is just an optional way in terms of how one of the technology creates them. So the first one we're going to look at is Google Sheets. Now this is one that's not recommended. There used to be an add-on to Google Sheets, but they stopped creating it, or the licensing, there were issues with that. So there isn't a general way in Google Sheets to create a full box and whisker plot like we're used to. But there is a way to kind of create a similar one. And in order to do that, we need to create or find 4 specific values. So we need to find our minimum, our Q1, our Q3, and our maximum. So I'm not going to go over how to find those values. We have talked about it before in our measures of spread lesson, so please go back and reference that if you need to. But in order to create a box and whisker plot in Google Sheets, you need to actually calculate those 4 values before you do anything. And then what you're going to do, you're going to highlight those values. I'm going to go Insert, Chart. I'm going to change my chart type. Right next, or kind of near histogram, is what they call a candlestick chart. I guess it represents a candlestick. So I'm going to click on that. Chances are it's going to show up something like this, which is fine. I just need to see all my data here. So the x-axis is what I want the titles to be underneath. So I'm going to change that to be year 2000. And the thing is, it does have to be text. It can't be numbers. It can be text and numbers, but it can't just be a number. So the low would be my minimum. So I'm going to click on that. The open is going to be the bottom part, or my Q1. So I'm going to find that. The easiest thing to do is click on this where it says select data range. Click on our point. Close is our Q3. So we can click on the box, click on Q3. And high represents our maximum value. And once I do that, I can see my rough box and whisker plot. Now it is vertical, which is fine. There's nothing wrong with that. And if I want to customize it a bit, I can change the vertical axis. I can change the minimum and the maximum value that I see. So let's make this roughly, say 55% to 95. So now I can kind of see it a bit better. If I want to, again, change it a bit, bring it up to 60. We get a better sense of what it looks like. Now, I wouldn't recommend using this because, again, we don't get to see our median. And the median is nice to see. It is nice to know where is that middle value. So this is a rough, this is how Google Sheets presents their box and whisker plot, at least for now until maybe some add-ons are created. As well, it doesn't show any outliers. So you're basically just kind of plotting these 4 points, and it recognizes I need to create a box for the middle 50%. So this is one way to do it. The second way that I'm going to show you is using Excel. Now you do have access to Excel through your student accounts. You do have access to all of your Microsoft Office tools, whether it's online. You do get an option to download them. So I'm going to copy my data set and I'm going to insert it into Excel. So we're in Excel now. So I'm going to copy it, and again, we're going to highlight it. We're going to go insert. I am going to click on, we see it kind of looks like a histogram here, but I want to go down to box and whisker plot, and I can see that it creates the box and whisker plot for me. Now, Google Sheets is a little bit difficult, or sorry, not Google Sheets, Excel is a little bit harder to customize. It's not as user-friendly, I would say, but we do want to show outliers. We want to show mean markers. We would show the mean. Should we take that out? I want to change my horizontal axis, if that gives me an option. Or sorry, my vertical axis. So again, go to vertical axis, changing our minimum to, we say we had 65 to a maximum of 95. And again, we do see it. Again, if I had to, I could go through and customize it a bit more, customize the chart title, customize the individual title here. But again, we can see our box and whisker plot, and we do get to see our median this time. So that middle line was our median, and we do get to see our max and min, and we do have the outlier. So again, the nice thing about this is that it automatically includes the outlier. If I were to look at Google Sheets doesn't include the outlier, and it doesn't actually calculate or assume that it's an outlier. So we would have to do additional tests or additional things to actually see that it's an outlier. So that's one thing to keep in mind. That's another downfall to using Google Sheets as well. But again, copying the data into Excel, inserting a box and whisker plot, it automatically calculates and includes that little outlier for us as well, and doesn't take it into account when doing our maximum and minimum. Again, it's vertical, which is fine. So that was the second option. The third option is what is using an online tool called Geogebra. And if you go geogebra.org, Geogebra, it would take you to this page. And you're going to want to go to Geogebra Classic down here. So if I click on Classic, it's already come up. It may have been already from what we've had before. But if it doesn't, what you want is you want to ensure that you have a spreadsheet. And generally speaking, if it doesn't come up, you may have to select it or choose it. Something on the sides. We should see this option though. White Bender's perspectives. You would probably be given all these. You want to make sure you select a spreadsheet so we actually get our spreadsheet. Again, you can copy and paste your data right into there from Google Sheets, because I do like using Google Sheets for all the other functionalities and ease of use. I'm going to highlight my data. I'm going to click on here with the bars that looks like a histogram. I'm going to do a one variable analysis. So I'm going to, which is kind of what we're looking at. So I'm going to click on that, and it's going to create a box plot. It also gives me the option to create a histogram. Right, lets me manually slide to change my interval size or my bucket size. So that is a benefit to this. I'm going to create a box plot though, and again, I can see my box plot here. I can see the outlier, and I can see my box plot. I can clearly see my median, the minimum, Q1, Q3, and my maximum. The only unfortunate thing about this is you would have to take a screenshot of this, or a print screen of this image. It does give you the option to export it as a picture, but when you do, it inverts all the colors, so it makes the background black, and it's not a very nice image. So you do have to kind of screenshot or cut out this part of our graph along with the values along the bottom. So there are some downsides to this, but it is online, it's free to use. Excel again is useful because very similar to Google Sheets in terms of functionality, just not as user friendly. But I wouldn't recommend using Google Sheets because again, we can see that it doesn't calculate the outlier for us. So I would stick to either a Geogebra or using Excel, whichever one you prefer. Excel is nice because again, you can just copy that image. Let's get rid of this one, and it pastes our image right in here. You can't edit it obviously, but if you wanted to kind of keep all your data together, that's an easy way to do that. All right, moving back. So distributions from box plots. So box plots do give us another visual representation of our data, and it is helpful to confirm the distribution or one of those four types of distributions that we saw with histograms, because sometimes we may be a little bit unsure of what type of distribution it is, but with a box plot we could be able to tell if it's specifically if it's a mound / normal or skewed shape. And with our mound and normal shapes, our box should be in the center, the whiskers will be the same length, and the median is in the center of the box. If it's skewed, the box will be on one side, one whisker will be longer than the other, and the median may be on the side of the box closer to the max or minimum value. So again, this is helpful because this kind of takes out some of the guessing if we're not too sure of the histogram, especially as well if we're not too sure of our interval size. So if we look at some examples, here we can see what a mound / normal distribution would look like as both a box plot and a histogram. So again, we can see kind of our box is in the middle, equal length for our whiskers, and our median is directly kind of in the middle of our box as well. And we can see that it represents this normal shape on our histogram. For the skewed, we can see that our box isn't quite in the middle. We can see that we do have one of our minimum whisker is longer than our maximum. We can see that this middle line is slightly more towards our minimum end. But again, it would at least tell us that we do have a skewed data or a skewed distribution. And from there, we can determine whether it's positively or negatively skewed. Again, sometimes the actual histogram might be easier to represent that, but at least now we know what we're kind of looking for or what we're trying to do. Finally, we can use our box and whisker plots and our histograms to make comparisons or to compare related one variable data sets. So if I'm looking at histograms, if I have two sets of data for, again, the same situation, the healthcare, if it was good or excellent, if I have two sets of data, one for the year 2000 and one for the year 2005, I could create two histograms and put them side by side to see what my data would look like or how it would change. And we could argue here, we can see a little bit of a skewed data in 2000, but in year 2005, you can almost argue it's getting closer to a more normal shape, right? Or again, normal shape, but being clustered around a higher percentage. So more people are grading their healthcare as at good or excellent. If we're creating box plots and we want to use them for comparisons, we would do this by having a side-by-side box plot or a stacked box plot. So this is an example of what it would look like for a year 2005 and year 2000 for our box plots if we wanted to represent them. Again, we can see how they're shifting. We can see how the middle 50% of our data is increasing, the median is increasing. Yes, there's still extremes on either end that they're different, but we're looking at the majority of our data, that middle 50%, and that is increasing. It's more, it's higher. So again, the standard or the percentage of people stating it was good or excellent has increased. And I'm going to show you how to create a stacked or a combined box and whisker plot. I'm not going to show you Google Sheets because again, we've talked about it's not the best way to do it. So I will show you how to do it with Geogebra and Excel. So if we bring up our Google Sheets just to copy our data, so I'm going to copy the data. I'm going to open up Excel. I have it already spaced out my year 2000, year 2005. I'm going to copy my data in here. I'm going to highlight everything and go back to the same thing. Insert, over to charts, find my box and whisker plot. If I want to format this, I can format my vertical axis. Click on the bar and that will show me, that will give me the options specifically. So I'm going to change this again to say 60 just to get a better view of everything. And again, it's automatically pointed everything out. I can adjust each individual one. I'm going to take out the mean marker. I don't want to see the mean. I'm only concerned about the median. So there was a little X there if you didn't already see that, or if you couldn't see it. And again, I can see my two data sets. I can adjust the title if I want to. If I go plus, I will add a legend so I know what years I'm looking at. I can add titles. I can take off the axes and so on. I can add data labels for each individual point if I really want to. But that would be my stacked or combined box plot. And I can make some comparisons or some discussions about how the data has changed from 2000 to 2005. So again, very easy in Excel. A little bit more challenging to customize and adjust, but again, I would say it's fairly easy there. For GeoGebra, it's going to be the same thing. I'm going to copy my data. Let me just close it, start back up fresh. Geogebra.org, GeoGebra Classic. So I do want to make sure that I have it clicked on the spreadsheet. It will probably give you a bunch of other things as well. I'm going to close the graph because I don't really care about the graph. I'm going to plot my two sets of data here. I'm going to highlight everything. I'm going to click, and I'm going to go down to multiple variable analysis because I have multiple things that I'm looking at. Oh, I put it on the other side. So here I can see my box and whisker plots. I can see both of them. I can see that I have the two different data sets, A1 to A13 and B1 to B13. I can see my outliers, I can see my minimum, maximum, and so on. I can see everything quite clearly. You may want to be careful. I don't believe it gives you an option to adjust the labels, so you probably have to be careful. Again, you can customize it a little bit, not as much as any of the other ones, so that is where this kind of lacks. But at least you can cut out or screen capture your box and whisker plot, and then you might have to add like a text box in order for titles and labels or legends. But again, two easy ways to use it to create your combined box and whisker plot. And again, that's it for the lesson today. So again, the main thing is understanding the different types of distribution and understanding how to create histograms and box and whisker plots using different forms of technology.